Really, that video is just thought process. I use it. I still use it today.
Obviously.
It may not work for you. If it doesn't, that's fine. I'm just trying to give you as much resources and help as I possibly can. So I want to roll through these.
Hold on. In adding to that, you literally did use it today. You said this. You literally used it today. Yes, continue. Never mind.
So we'll roll through these and we'll get through the last two nomenclature rules. I will look at you and tell you the last two nomenclature rules are quite interesting.
Let's not.
And it opens up our world
Let's not.
a little more. So within this, first one we got is hypobromite. This is a polyatomic. That's how we name polyatomic. Hypo in the front. Remember what I like to do? I always like to look at the root. So the root is the 8. So bromate. Bromate's what?
BrO3 negative. No.
So BrO3 negative.
Yeah.
So in this, hypo means it's 2 fewer than the root. So 2 less oxygens, so 3 minus 2 is 1. So hypobromite, BrO negative. Okay? We're just going to move down. Sodium nitrate, tribe. Check to make sure. Sodium nitride. Sodium nitride does not have a polyatomic in it. So we're looking at it. Sodium, because in the S block, left staircase means metal, bonded with nitride, which comes from nitrogen, which is a non-metal, which means we're dealing with an ionic bond. So let's get the ions down. Sodium's Na with a +1 charge. Nitride comes from nitrogen, which is N, and it comes from the 15th column, which means a 3 negative charge. So now we cross these charges over because it is not a 1-to-1 ratio. If it's a 1-to-1 ratio, it just literally simplifies out. So we have Na, 3, N.
Last time we did these, you were talking about how it was weird that we went up and down, so because you did them across, and now that you're...
I flipped it.
Yeah.
I was
What's
waiting.
even-
Honestly, I did not think you were going to be the one that was going to mention that.
What's even weirder, hold on, to add to this, he went up and down here, up and down there, and then he mixed them right there. Which it's symmetrical, and I kind of like it though. Because if you turn it sideways, then like, it
What
matches.
What? Nixon. What are you talking
Okay, we did the chemical formula.
Oh, okay,
chemical
okay.
chemical formula.
about? Okay.
All right, anyway, so nitrogen. Anybody know what nitrogen is?
N2.
Why is it N2?
Because it is a,
Diatomic.
I was going to let someone listen.
Diatomic, which means it exists in nature, naturally bonded to itself.
Science.
Trick. What?
What?
So let's move over here now. PO5. I will look at you and tell you this is a trick. Shut up. So PO5. What's the name?
Phosphorus pentoxide. Phosphorus pentoxide.
Why is it phosphorus pentoxide? Why is it not perphosphate? There's no charge. Just because it looks like a duck doesn't mean it's a duck.
Looks like a duck, quacks like a duck. must
Because
be a
if
duck.
it's not quacking like a duck,
It's a chicken.
it is not a duck.
Probably a duck. It's probably just.
There's no charge.
It's a goose if it's
It's because it goes honk.
So,
And just because it goes honk.
non-metal, phosphorus, oxygen's non-metal, so you name it using the prefixes. There's a 1 here for phosphorus, so you put no prefix with it. Phosphorus.
Science.
Prefix for the second one, 5, so pent.
And since, you know, it would be...
Oxide.
I didn't get that one.
Oh.
It's alright. It's a trick. Thing of it now is that you see the trick. I loved how I got the looks in the room. Like, what do you mean if it looks like a duck? It's not a duck.
It must be a duck, Mr. Hall.
Remember the saying, if it looks like a duck, it sounds like a duck, it smells like a duck, it acts like a duck, it's clearly a duck.
I don't know about that.
Yes, and I also got flogged by a duck one time, and it was not fun.
Hey, I was a little baby.
Baby duck.
Not a little baby, but I was
And I
young.
was trying to pick the baby duck up, and the mama duck came at me, and I was chasing her, and I was running.
See, that's what happened to me. It's like me and my friend was like
But I
chasing
still-
after these ducks,
Yeah.
and they had like the baby ducks behind her, and the mom's like running, and the baby ducks are following her, and as soon as we had grabbed one of those baby ducks, Mama turned a 180 and came straight at us, and I was like, oh God!
Okay, so I haven't seen this for you. When I was younger, I used to live in like an apartments, and you know how there's like drainage ditches between them? Well, it had become like swampy at the bottom of those because the drainage was messed up. So cattails had started growing, and the ducks would hide in those cattails. And when you got up to them, you couldn't see in them. So I had one of my buddies like stand up on his and look down and tell me where they were. So I like eased up to it. He was like, they're over there. So I jumped in and grabbed a duck. And when I did, I didn't know where the mama was. Yeah, it didn't go well.
Found out real fast.
We ended up running inside with the baby duck, and she tried to follow us.
Oh my God.
I kept that duck.
Alright, so BaCO4. So BaCO4. Is there a polyatomic here?
Yes.
Yes.
Charges it.
CO4. I'm telling you, dead giveaway. 3 elements. If you watch the video, I literally break it down from 2 elements, and then I break it over into 3 or more elements. That's how I break it down. There's 3 elements here, which means there must be a polyatomic here.
Okay.
So within this, you find the polyatomic. This right here clearly is the polyatomic. Is it in parentheses? No. Which means it has the same charge as whatever the overall charge is over here for this cation. So what's the charge on barium?
2 positive.
Positive 2. This is just good practice. How many bariums you got?
1.
So 1 times positive 2 is positive 2, which means the overall charge over here for this polyatomic must be equal to that, but opposite in sign, so negative 2.
Quick math.
So we name it. You name the cation based off naming the monatomic cation.
Barium.
So barium. Then CO4. Percarbonate.
Can you tell me what the bird?
What's the
Miss
root?
Brenda Smith to the
Carbonate.
office. Miss Brenda Smith.
Think back to your memory of those lovely polyatomic ions that I know you guys all have memorized, and never set those out on your desk and look at them anymore because you have them so in memory.
I didn't
It says pulls his binder up and covers his. Okay, carbonate.
I was talking about
CO3 2 negative.
I'll see.
CO4, that's 1 more oxygen. Since you have 1 more oxygen, that means you add prefix per.
Will there ever be a time where you would put barium, carbon, and
No.
Now, huh?
So,
Oh, I see what you're doing. Never mind.
C2 has 4. Is carbon a metal or a non-metal?
Carbon is non-metal.
Non-metal. Is sulfur a metal or a non-metal?
Non-metal.
So it's a non-metal bonded with a non-metal, which means what type of bond?
Covalent.
Covalent. So how do we name our covalent
With prefix.
molecules? Using the prefixes.
Carbon.
So we look here first, we have carbon. There's a 2 with it, so do we give it a prefix?
Yes.
Yes, the only time you never get the prefix is when the first one is mono, has 1. But this time it has 2, so it's di-carbon. Then we have this force, put the prefix for force, tetra. S is sulfide. Dicarbon tetrasulfide.
See, I understand the ones like that. Like the one above it where you got the two ones.
But that's my thing is, like, what I said, if you go back to what I said before when we learned the first 3 naming rules, I told y'all, do not get tricked by this. This is not simplistic. That it's going to get confusing when we add it all together. Which we still haven't added it all together yet because they have to get the last 2 rules in.
Rude.
So, let's move on. To the NiCO2. How many elements present? 3, which tells you what?
That is
There's a polyatomic in there. Where's the polyatomic?
CO2.
CO2.
Should be CO2 2 negative.
Okay, it's CO2 2 negative.
Why?
How do you know that?
Because it's covered up by the nickel. The charge is covered up by it.
But isn't nickel
Yes.
D-block dude, so can't nickel carry multiple different charges?
Yes.
Yeah,
So how does nickel help you figure out the charge?
Because it does. Because I said
Roman
it.
numeral?
I don't know that they're all.
You said Roman numeral?
You are going to use your Roman numeral on this. You're going to use stock system. But
So,
Wait a minute.
I thought it was because there was a one ratio.
Yeah.
that tells you the charge here.
equal.
But how do you know here?
Because it's,
What are you doing?
Because that's how.
in order for it to be canceled out, I know that Mr. Paul, yes,
What's that?
carbonate.
Okay.
And CO2 is carbonate. Well, CO2 2 negative.
So what polyatomic ion,
Oh,
and do y'all know that involves carbon and oxygen?
Carbon.
It just told me its name. Carbonate. And then that's the root, and then from there you break it out.
That's what you want.
So from there you know the charge of it because based off of that. This is a really good question because you have to know your polyatomics hands down.
Sadly.
Because now you're going to have to know this is carbonate. It's one less oxygen, so what's CO2?
Carbonate.
Carbonite. And so we know there's a 2 negative charge there,
It's a 1 to
which
1 ratio.
means there's no parentheses around it. There's no extra number down here for nickel, which means it's a 1-to-1 ratio, which means what's the charge on the nickel?
2.
A 2 plus. So now you're going to have to use the stock system because nickel can carry multiple different charges. So within this, you're going to have the nickel 2 because of the charge. Remember, that Roman numeral tells you the charge, not how many there is. Nickel 2, carbon
I.
Today's going to be a good day. As soon as I wrote that carbonite down, my juices are pumping.
you do one with like, it's already in the fridge.
Regular old
Well,
day
those are
chemistry, you say? No, says
I'm already,
I.
my blood's pumping now and I want to get to the last 2 rules. Sulfur dinitride. Key to it. Di. You see a prefix. It's spelling it out for you.
Quick maths.
Which means this is literally spelled out for you. Write the elements down. Sulfur. Nitrite comes from nitrogen. How many sulfurs we got?
1 because it's mono, but we don't put prefix.
1 because there's no prefix there. How many nitrites we got? 2 because it's literally spelled out for you. Di. This green marker really is new, but it sucks.
Gotta break
It's
it
not
in.
polymer.
Gotta break it.
And then a really good trick question here, F2.
Fluorine.
Why fluorine?
Because it's a diatomic.
Diatomic, which means it exists in nature, naturally bonded to itself. First anything you're going to get from my class when you get there, you will know you're 7 diatomics.
That's exactly right.
So, there's some practice for you all. It was great, wonderful, and fantastic. Now, how excited are y'all to learn these last rules?
Yeah.
Woo! Get juice!
Yes, sir.
Here we go.
Because if I do that, then if I, yeah, that's not.
So ladies and gentlemen, today we finish up the nomenclature unit
Speaking of English.
with the last two nomenclature rules. Now please, hold your excitement. For today, you're going to learn how to name something you all would get excited about.
What's that?
Today is acid nomenclature.
Let's not. Wait a minute.
So within this acid nomenclature, what you will find out, there's two different types of acids you'll deal with. The first one is a binary acid. That's the first rule you're going to learn today. And the second one is the one that you all will dread, but be so excited about, or what we like to call oxyacids.
Now,
So within this, it brings us to a very exciting point within chemistry, because you're going to have to be able to determine the difference in the two cases. So let's start with the binary acids. So let's hit the highlights. First thing is binary acids. The key is in the name, binary,
two.
which means two elements. So it's made of two elements. Now, within this, these two elements, you can pretty much look and say it's going to be a set of a certain something or another. It's not going to be just whatever. Okay, we're not going to throw these two elements together and say there's an acid. It doesn't just work like that. Because here's pretty much the guidelines of these two elements. The first one is always I mean always in a binary acid, hydrogen. Atomic number 1. This is the key. Acids are proton donators. The way we define acids are literally based off how much hydrogen ions are within a solution. Will they give off hydrogen ions? So the key to that is there must be hydrogen with it.
Okay. So one of those two elements is always going to be hydrogen.
The first one, always hydrogen. Always.
Gotcha.
Second one is normally, I mean normally, okay? Like this is normally what you'll see with it, is a halogen. So like chlorine, fluorine, bromine, iodine, that's what you're looking at with them. So here's how you pretty much break it down. The naming for it. This one is not too bad. When you're naming a binary acid, you get a prefix to it because of the hydrogen. The hydrogen gives you the prefix hydro. And you guys have heard this before. You just hadn't realized it. And then you change the ending. You know how we've been changing the ending on everything, but we changed IDE? We now will change the ending to the suffix "ic." So this pretty much is the generic way that you're looking at it. When you're naming a binary acid, you have hydro, and then in the middle, you're going to have the root of the element. And then at the end of it, you have ic. So hydrorutic. A perfect example of this, you guys have all heard it before. HCl. Here's the key, and I'm literally going to give it to you. How do you know you're dealing with an acid? Look at the first element. Anytime in this class you're dealing with an acid, hydrogen will be first. The key is hydrogen will be first. Just because hydrogen is in it does not mean you're dealing with an acid. This is an acid, HCl. CH4 is not an acid. What comes first? Carbon, not the hydrogen. So this is not an acid. HCl, what comes first? Hydrogen. You're dealing with an acid. HCl, you know it's a binary. So it's 2. You name it based off those rules. So first thing you're going to do, you'll always have the prefix hydro. Look at the second element. You're going to name the element. So chlorine.
What was that name? The hydrogen.
But then you're going to do what you've already been used to. We're going to remove the ending off that. So remove that I-N-E and put the suffix ic. Hydrochloric. Now technically you can stop there, but I don't want you to stop there. It's an acid. So put acid at the end. Hydrochloric acid.
Can't you like make that for like male bodies?
Well, it's what's inside your stomach that breaks down all the food. Alright, so in this, if I gave you hydrobromic acid, work it backwards. Here's the key. I'm literally going to give you the key right here. You see acid. When you see acid, you know go acid naming rules. Step 2, look at the prefix. The prefix will tell you what acid you're dealing with. You'll see here in a second. Hydro. What does hydro mean?
It means it's a binary acid.
It's a binary acid. So you know it's made of 2 things. What's the first one? Hydrogen, because hydrogen will always come first. So, H. What is hydrogen bonded with?
Bromine, because bromine.
Bromine. So, because brome, it's the halogen, bromine.
Yeah,
It's there. It's the root, man. So, Br. Now, this is the thing. Why is there only a 1-to-1 ratio here? This is as to why. You put the number of hydrogens there for the charge of the second element. So all the halogens come from what column?
Everything.
Which has what charge?
-1.
-1. I just thought you said that way as you're yawning. You're right though. It comes from the 17th column, so it has -1 charge. So we only need 1 hydrogen. The hydrogen's hiding the charges. You guys good?
Yes, sir.
Simple enough?
For right now, until you decide to say, hey, here's a
Not
trick.
that complex, right?
So far.
Yeah. So let's throw a wrench in it.
Let's not.
Here's where life gets interesting. I warned you. Hopefully you have started to learn to heed Mr. Hall's warning. I'm not giving you a lot. Oxyacid. I warned you, and I warned you, and I warned you to get this.
Yeah, I'm just gonna wait for you to draw that. I'll do it after you do it.
This should look familiar.
I'm not.
Oh, hold up.
Like,
Polyatomic.
is this the same thing or is it for oxy?
We're going to change it,
Okay.
but it's based off of oxyanions. How did you learn the name oxyanions? I warned you and warned you. Make sure and get that because we're going to base the last rule off of it. Here's your last rule. You have learned all of this. You learned about rootate.
About what? Oh,
Perrootate.
I thought he was talking about some.
Rudite. And hyporudite.
No.
You learned what this meant. That's one more oxygen. Then root. Rootate is the most common. That's the one we memorize. So we can build off of it. Rudite is one less oxygen than root. And hyporudite was two less oxygen than root. This column is your polyatomic suffix. Now we're changing it. This is your oxy acid suffix. We save the best for last, ladies and gentlemen. Here is the golden rule. Whenever you go from polyatomic suffix and go to oxyacid suffix, the rule is 8 goes to the suffix "ic." "Ite" goes to the suffix "us." O-U-S. Everything stays the same, but the ending. So you have perute. But what's the ending? 8. 8 goes to "ic." Root, "ic." Root, "us." Hypo, root, "us." We're going to need another column. It's the same thing. How do you know you're dealing with an acid? Hydrogen's first. Hydrogen tells you it's the acid, and it's the same number as the charge of the polyatomic. Bless you. You have the basis for this. Tomorrow when you come in, I will finish here I need like 5 minutes, and then we're going to practice. There's no holding bars. Nothing's being held back. All out, ladies and gentlemen. You can do this. Come see me. Stop waiting the last minute. This is where we'd stopped yesterday. We worked for those binary acids. Before we jump in and start working the rest of these practice problems, okay, for you, I want to make sure that you get a decent feel for this besides just like a surface look at it. So this is what we left off on yesterday, just bringing it back together, this oxyacid nomenclature. This is all about the oxyacid. Remember, what's the key to an acid? It has hydrogen in it, but not only is hydrogen in it, it's the very first one. Just because hydrogen's in it doesn't mean it's an acid. Hydrogen has to be first. Then it's the same thing here for this oxyacid nomenclature, which you'll see here in a moment when we work these example formulas over on the side. So on this, everything I've warned you that it was going to be based from here, that you needed to get this. Talking about this oxyanion nomenclature, man. So talking about these polyatomic suffixes, that the per-rootate is one more oxygen than the root. The rootate, that's the most common one. That's the one you should memorize, because if you memorize it, you can work from it. Know this one, rootate, okay? So rootite is the one less oxygen than the root, and hyporootate is 2 less oxygens than the root. This is the key. Everything's in terms of the root. Alright? Now in this, everything stays the same except one little subtle itty bitty difference. You're going to change the suffix. So if there's a prefix, it's going to stay the same. So for these per-rootates, the per will stay. And down here for hyporootate, hypo will stay. But here's the difference that gives you the change. We will literally take the suffix "ate," so ate, and it will change to "it." Now I gave that to you yesterday, and I also said at the end of it, we're going to write acid. For some reason,
that's it.
Us chemistry people, we just don't like to just leave it there. We won't look and say perutic. Technically, if you know the rules, it's an acid. I guess there's something about it, like, it's like you, whenever I look at you and say, guys, we're going to deal with some real deal acid in the lab this week. You guys get all juiced. You're like, whoo! Dealing with the real stuff now. Yeah!
It's going to burn our faces.
So, for some reason, just put it there. Okay, it does count. I had somebody ask yesterday, I think it was you, Seth, asked, if we don't put acid, is it wrong? Yes, it's wrong. Acid has to go there. That goes for the binary and the oxyacids. Then, you have another change. We'll change the suffix of ite, I-T-E. It will go to the suffix us. O-U-S, and we write acid at the end. So everything stays the same, but we change the ending. So, ic, perutic, rootic, rootite goes to root us, hyporoot us, and you write acid at the end of all of them. I did. These are flipped. I thought it fit better this way so that you can see the switch.
Yeah.
But if it's flipped, then you're fine. You still got the same thing. This is what happens when I don't reference to go off of from last year, and I'm like, man, I should have flipped those two. I'll just roll with it. Okay, so, an example to deal with, okay? I want to use one that's going to help you see how you're going to use these hydrogens with it. So, we're going to do everything off of the root of phos. So, we're going to do perphosphate. Okay? So, here's the key. What is phosphate?
PO3.
PO4 3 negative. That's phosphate. Okay? So when we're looking at up here, I'm going to perphosphate. That's one more oxygen. So the perphosphate is PO5 3 negative. Here's the thing. To make it an acid, what has to be the first element?
Hydrogen.
Hydrogen. How many hydrogen? This is the key.
3.
The charge that's on the polyatomic. You got a charge of 3 here, so put a 3 down there. You put the 3 down. That charge is hidden. Take that away. And that's literally what we're going to do on every one of these. So working through the names first, perphosphoric acid. Ran out of room. It's perphosphoric acid. Then down here you have phosphoric acid. Then we go down here, everything changes because now, you okay?
I'm just having a bad day.
Understand, I'm sorry. Get a moment. You get that phone. I'm sorry, man. Break my heart. I'm gonna cry.
Don't do that.
Rudus, acid, so phosphorus, acid, and then we have hypo, phosphorus, acid, so then from here, working the formulas. You've seen it before. This is literally the trick of how I do it. I start here. I start with the polyatomic every time. Even if you don't see me write it down, I'm doing it mentally. So, perphosphoric acid. It came from 8. So I'm dealing with perphosphate. So, perphosphate is PO5 3 negative.
No, Mr. Hall.
Perphosphate
Oh,
is PO5 3 negative.
I thought you said phosphate. I was confused.
I said perphosphoric acid comes from perphosphate
Okay.
because
I was
it comes
confused.
from 8.
Whenever you said that, I was confused. Yeah. We're good.
So I'm going to add hydrogen, turn it to an acid, and I look at the charge to tell me how many I need. I got in 3 negative, so I need 3 hydrogens. And then I just erase the charge. Phosphoric acid comes from phosphate. Phosphate is PO4 3 negative. Turn it to an acid. Hydrogen. Got 3. Good job. Erase the charge. You have to take that charge off. Those hydrogens hide the charge. Yep.
Well, finish. I'll ask later. My bad.
Okay, you're fine. Phosphorus acid, that doesn't roll off the tongue well. Comes from phosphite, was PO3, 3 negative,
H3.
H3.
Respiration 3 negative.
That's 3 negative. You're catching on quick.
Next one would be PO2, then you have H3.
Hypophosphite, PO2, 3 negative. Then we're going to turn to that acid, so throw the hydrogen down, 3 because of the 3 negative. Brace it.
So, we wrote down, whenever we were talking about binary acids yesterday, we put down the first element was the hydrogen. It's the same thing across.
Same thing for the oxyacids. Hydrogen must always be first. That is the golden rule for acids
So this was the only thing I missed yesterday.
and binary acids, which they're simple. It's binary is 2, and the first one is always hydrogen. The second one is typically, normally, and in this class will always be one of the halogens, so 17th column. You get a prefix hydro for hydrogen, then you take the root of the word, so if it's HCl, there you go. So HCl, hydro for hydrogen, chlor for chlorine, and then change the ending to ic and acid. Are there questions here?
It's add hydro to your root.
But it'd be like instead of like this would be hydro, like
They break a rule.
whatever, like.
It'd be hydro.
Then chemistry, for every rule you got rule breakers.
Hydro. No. Or
Yeah, sure, let's do no rules and you guys just memorize everything.
Just HCl.
Let's just not memorize anything, because if there's no rules, we don't have to remember it. That's what we got. Let's do it.
It's the one that breaks the rule. Just memorize those things. From there, to my knowledge, yeah. All right,
Got hydro.
here's this. I'm going to give you, here is the first sheet. I think I actually got enough printed to do this. If you do not end up with a sheet, please tell me. Also with this, please attempt these, okay? I want you guys to attempt this. You can ask people around you for help. You can ask me. I'm fine with that. I will work with you. We've got to get you to where you can do this for what is to come. You also can bring this sheet to me for questions. I do have to cover a duty spot today during first lunch, so if you're looking for me, I will be outside the janitor area.